Well, this is something a bit different today. It's a powered mixer, so it has amplifier built in. It's a mixer, and belongs to a company who are in the same commercial centre as me, who sometimes brings me stuff to look at. Thing is, he only speaks some English, and I only speak some Spanish. So we kind of like communicate with a mixture of Spanglish and like gesticulation, yeah, and Spanglish. So I don't understand it. He was saying that there was a problem on one audio channel making like woof, as he said, woof, woof. I think maybe it says coming and going. I don't know. But I can't actually get any audio out of it at all. I've got a couple of speakers attached to it. I've got audio feeding in here on this channel, and I'm pretty sure I've got it set, you know, reasonably, but I don't get anything out of it. So these are your main sliders, and you'll notice that on the audio here, if we just get, there we go, this red light's flashing, so effectively you can see the audio going up and down, yeah. But this one's behaving strangely because this red light keeps flashing. I don't get any audio, nothing out the speakers, no hiss, no pops, no clicks, no bumps when you switch it on. If I plug my headphones in, I get audio out. So my best guess is that something's set wrong, or something isn't working. And that's the problem. I can't find an actual user manual for this. I'm kind of going on like my sort of like previous experience with mixers, really. I mean, they're not that complicated. But yeah, I don't have anything out. I asked online if everybody else could suggest, and I took a photo of all the positions of all the switches, and nobody seemed to think anything was particularly set wrong. I've tried everything anybody suggested. So yeah, that's the problem with it. It's either set wrong or it ain't working. And the best way I think to find that out, I think maybe the amplifiers are not running at all. I mean, it's possible the guy who brought it to me with the Spanglish, we kind of slightly misunderstood what the problem was. And this, I'm sure, is wrong, yeah. So what I'm going to do with this is I'm going to open it up and see if I can disconnect the main power amplifier from the rest of the machine, yeah. Because there's probably like coming out this mixer like an audio cable going to the amplifier, and I'm thinking if I can inject an audio signal there, if I have my own little mixer, I can probably use that to do it. If I can inject an audio signal directly into the amplifiers, we can then prove whether the amplifier is working. If they are, then I suspect that I've got something set right. I doubt it's actually a problem in the mix. I think it's more likely something set wrong. The fact these are going up and down tells me I've obviously got signal, yeah, coming in and out to the headphones. Okay, so I'll try and get this opened up, and then let's have a look to see what we've got. Hi guys, I've got it apart. It wasn't too difficult. It was just screws down the side, across the back and across the front, and I'll try and show you what I can see in it, what I can see. I'll just get my headphone wire, there we go. I can see already there was a problem in here. So down inside here, so I get the camera into position where you can see it, yeah. So down inside here, this is the input to the main amplifier. There's some ribbon cables that run down here, and after that torch you can probably see a little bit better. There's some ribbon cables that run down inside here, yeah. But under here is probably the main amplifier board, or I can see part of it. I'm guessing that all this metal stuff here, this is the effectively where the output transistors are. It's a heatsink, yeah. And what I found is, if we come down this side here, let's see if we get the camera into position where you can see it better. Okay, yeah, there's this ribbon cable here. So this appears to me to be the main outputs from the mixer, because it's underneath, you know, where all these controls are here, yeah. It's underneath here, yeah. There you go. And this circuit board is under there. I've noticed another thing, all the ICs are on sockets here, so it's obviously designed to be kind of like worked on, yeah. I'm a bit surprised they don't fall out. Obviously these things live on the road and they get a bit of hammering, yeah. But what I spotted anyway was this connector here is not pushed in properly. So I'm just going to try and seat this into position. Yeah, it's gone now, it's clicked, yeah. That's clicked. So that's clicked in place now. So I'm hoping now we might get something out of the speakers. I mean, the fact if the main amplifier was disconnected from the mixer at that point, then we're not going to get any output. So let's just get a bit of audio or something going, and then we can try it. You never know, we might just be lucky here. So that's some audio on the computer. Power's unplugged now, obviously. I'll switch it off. Power's now on. I'll turn the output down. Yeah, let's just see if you can see this on the camera. Let me see what you can actually see. Okay, yeah. So I've got the main output on the mixer turned down now. Move this up a bit, yeah. This thing is so big. Yeah, so these are the main outputs they turned down, yeah. Let's just see if we can just prop this into position. Ribbon cable still on. Outputs turned down. Let's power it up. You can see the display thing here. And let's see. One thing I forgot. Let's connect the audio to the input. I'll turn the input down. Audio from the computer. No, that obviously was not the problem. This is still flashing red. Okay, so I think now we're going to have to get us further apart, but it looks to me like we can, once we've dismantled it a bit further, check the input into the amplifier, and we can effectively take the mixer section off, so we just have the amplifier board, and then we can get a bit further with it from there. Well, I was just going to start dismantling it, and then I realised that I'd unplugged the speakers as well as unplugging the input. I'd also unplugged the speakers. So again, I've turned the output all the way down, turn it on. Now let's see if we get anything coming out of these speakers. Input. No, definitely not. At least the speakers are connected now. I've tested the speakers, I know the speakers are working. So yeah, we have to start getting in this to see what the problem is. Okay, so I've managed to disconnect this now. Basically there was just a few ribbon cables, so there was two here, a large one here, another one from here, and then this one was one that had previously fell out. I mean, I think if we look at this, I can just move it up here a bit, yeah. So these are all your main sliders, yeah, and it's fairly obvious that coming from the main sliders there's a load of wires going to this board, yeah. And then there's ribbon cables also going to this board, one coming from across all these, another one goes out. This I think is an interface which drives that display, the fancy display, yeah. So it does make sense that this is the audio out coming off the mixer. And I'm guessing probably one of these is power. I don't really know exactly what any of these do at the moment, so we can only guess, yeah. So this is the actual what's effectively, this is what's inside it. We can see now. I'll put that safe. Yeah, so this is the display, which has a ribbon. So this goes to the mixer. So I'm pretty sure that must be controlling this. Two of them actually go to there. This one goes down to this board here, which has on it at the back some connectors which are amplifier insert, some sort of connectors there to do with the amplifier. I can now see this is the power supply, yeah, so you got your big transformer, linear transformer in this, and these are your bridge rectifiers. So this will have a plus and a minus voltage rails, yeah, like maybe plus 50, minus 50 for the amplifier, maybe a bit more depending on the amplifier rating. A lot of capacitors, so you've got your bridge transformer, bridge rectifiers, capacitors, fuses, and there's probably voltage regulators or something similar to that. And I'm guessing the audio comes in from the mixer panel onto this circuit board, and then looks like it goes across here. The main amplifiers under here. I think I can take this off. Just danger high voltage. Danger high voltage. It's obviously quite compact. Yeah, the speaker connectors are here at the back, so they're coming off there. This is the amplifier. This is the main amplifier. So what I'm trying to do is really now to figure out, do we have any audio coming out of the mixer panel? That's one thing. And I suppose the best way to find that out, because it's difficult to work on that mixer panel when all this is connected up, would be to see if we could find where the audio inputs are into the amplifier and inject a signal directly in there. If we get sound, and I'm guessing those inputs are on somewhere on this cable, yeah, somewhere on this one. If we then get sound, then we know the amplifier is working. If we don't, then we can work on this. If we do get sound, then we've got a problem in the other half of it, which is going to be, you have to try and figure out how to work on this. It may be that the only way to work on this is literally to make some longer cables, yeah, to actually make some longer IEC cables so we can get it in a position where we can actually do some work on it. Let's take a look what's under here. Wrong screwdriver doesn't fit. I mean, another possibility is we can check to see if we have power coming to here. That might be a good idea. We've got fuses down here. We can see power coming in from the big transformer. So we can also check to see if we have any power getting into the amplifier, yeah? So there's a few things we can check now. If we've got power going into the amplifier, then we can look to see where the input is. I'm hoping it might be marked, you know, if I look on the amplifier, there might be some sort of marking. It would be nice to have a schematic for this, obviously, but I did have a look. I couldn't even find the user manual, never mind the schematic. Screw isn't even screwed in properly. This is the company who are in the same centre as me. Power Sound. He has a little workshop. He does some work, like he fixes speaker cones and things. He does a bit of soldering. He is not an electronics engineer, but he can certainly deal with a lot of simple things that go wrong. Okay, so we can see the amplifier board. That's quite nice. 2 channels. I'm gonna have to just unsolder that. No, it comes off. I'll probably just get rid of that. Looking now down under here. I'm not sure that there's 2 circuit boards above and below, yeah. I'm not sure. I can see some power transistors on the bottom one as well. Right. If we unplug the speakers and the power lead, this is switched off on my isolator. There's obviously some sort of amplifier modules here. There's something there. At the moment there seems to be rather a lot of circuitry in this for an amplifier, yeah? I think we can see these are output devices. 1, 2, 3, 4, 5, 6, 7, 8, yeah? Considering it's stereo, then I think we can pretty much say that we have 2 output devices on each half phase. Like this is a push-pull So like one amplifier is angling like the negative half of the waveforms, the other one's the positive half, yeah, and the same for the other channel. So it'd be something like positive half of the cycle left channel, negative half of the cycle's left channel, positive half of the cycle right channel, negative half of the cycle left channel. I'll have to draw you a little diagram. I can make a bit of space on the desk to show you how this effectively is connected up. We can see where power's coming in. There's more fuses down here, even more fuses down here. Let's check the fuses. See if any blown fuses. Yeah. Let's see if we've got any fuses blown on here. So 1, 2, 3, 4, 5, 6, 7. All the fuses looking good. Some more here. 1, 2, 3, 4. And I've seen another one somewhere. No, oh yeah, down there. 5. All the fuses check okay. I'm looking at this now. I mean, obviously, this is your main power supply, yeah, your power supply rail for the amplifier. These here, these voltage regulators, I'm sure they will be all transistors. And this, I'm pretty sure this will be like the power supply, like kind of like the pre-amplifier, or to the mixer section that sits on top. So that feeds onto this one, and then maybe feeding power back up here as well. This may be carrying power and audio because the mixer section won't be drawing much power. Yeah. This appears to go to the to that. I'm guessing that's like data for this. Yeah. They're all okay. Next one, I guess, then to check is going to be checking for power here on the output. Yeah. So if we can find a ground, there must be plenty of places we can find a ground on here. Maybe even to the chassis. Yeah. Then we should be able to see. I can see cables coming in here and here. So this looks like the power rails. One here, one here. I'm expecting to see like a plus and a minus, one here and one here, with respect to ground. Let's try and find a ground. I'll just go for the little tag at the back of here. There's a good guess, wasn't it? Somewhere in the middle. Looks like I found a ground point. Yeah, there's ground, yeah. So what I'm going to do is I'm going to switch it on and have a look here and here, for the power coming in, because I'm pretty sure that's where they will be coming in. And the reason I'm pretty sure is because of these big thick tracks that get up to the output devices, which are obviously here, yeah. So I think we can say with confidence that this is where the power comes in. I think we can also say with a lot of confidence this is where the audio comes into each channel. Okay, let's plug this back in and have a look to see what we can do. I'm just going to power it up just with I've actually disconnected the speakers. Don't want any loud pops and clicks, you know, damaging my speakers basically. Power coming in. Let's get out of the way. Power on. Fans running. So I'll go to that ear tag. Let's see what we got here. Voltage. I'm expecting to see quite a high voltage on this. 88 volts, yeah. 43 volts. Oh, okay. I'll tell you why. 88, 43. There's a negative side as well here. 1.3. Nothing. I'm pretty sure I should find a negative. Yeah, minus 43. I'm expecting to be a minus 88 somewhere. I'm not sure I'm seeing the right voltages on this. I'm going to have to draw this for you guys so you can understand what we should be seeing, and then we'll come back and we'll have a look to see what we actually have. So before we can repair this, we have to understand how it works, yeah? If you don't know how it works, you can't really fix it unless it's like something obvious that's burnt or something, yeah? Okay, so to do that, you have to know a little bit about audio amplifiers and classes of amplifiers, yeah? So audio amplifiers come in like class A, class B, is a class AB, there's class D, G and H, yeah? So those are the various classes. The class of amplifiers got nothing to do with the quality of the audio, although some purists will tell you that class A have the best quality audio. But the class is not a measurement of its quality of audio, yeah? The class is the way the circuit is designed. And this is not a lesson on amplifier classes, so we're just going to talk about what we need to know to look at this one, see if we can fix this one, yeah? I can tell you now, this amplifier is a class G, yeah, it's a class G amplifier. I knew that straight away when I measured a couple of voltages, and I think it's got a problem to do with power supply voltages as well. So how do I know that? Well, to understand the class G amplifier, first you have to understand the class B, yeah? So a class B amplifier is basically like this. You have a positive and a negative supply, yeah? And you have a ground. So your power supply basically comes from a transformer like this, yeah? So you've got AC in, yeah? And on the secondary winding, you've got a centre tap on the winding, yeah? This here is your 0 volts, yeah? And if you measure from that, obviously there's diodes in here, rectifier diodes, yeah? And there'll be capacitors. So you have a power supply basically like this, yeah? 0 volts. And if you put your meter on 0 volts, here you'll measure the positive voltage, and here you'll measure the negative voltage, yeah? So for instance, if this transformer was 24 volt transformer, from here to here you'll read 24 volts. But measuring from ground, which is your reference point, this is plus 12 and this is minus 12. And that's how you get the positive and negative rails, yeah? So the way your class B amplifier works is you have a PNP transistor, yeah? You can do this with MOSFETs as well. Well, this is bipolar transistors, okay? And then you have an NPN transistor. Like so, yeah? This here connects normally via a capacitor to your input, yeah? Okay? Input is between here and 0 volts, yeah? Ground, 0 volts, okay? Then there'll be resistors to bias both of these transistors. A resistor network like that, and this is designed so that under normal conditions the transistor is just switched on, so it's just at the point at which the transistor switches on, yeah, with no audio input coming in, okay? From here this goes to your speaker, yeah? From the other side of your speaker goes to ground, 0 volts, yeah? The centre of your transformer winding. So that's basically a class B amplifier, okay? Class B. And the way this works, basically, this is biased with these resistors. So there's just like 0.6 volts negative difference on the base to emitter. Negative because this is a PNP, yeah? So to switch it on, the base has to be lower than the emitter. And on this one, it's positive, so there's plus 0.6 volts. This is an NPN, yeah? So both of these are just about turned on. When you get your waveform coming in, is a waveform, yeah? This is 0 volts to center your waveform. When it goes into the positive half of the waveform, through the capacitor, AC passes, yeah, DC doesn't. That's why we have a capacitor here, because we don't want any AC coming in here, sorry, any DC coming into here and interfering with the bias of these two transistors, yeah. So when we go to the positive half of the cycle, the voltage here goes up, yeah, and the voltage here goes up, which is on the positive half, yeah. When the voltage on this base goes up, the difference between the base and the emitter decreases. This was set to minus 0.6. This is plus 0.6, yeah. So this transistor switches off. It was just about switched on. The voltage increases, so it goes like minus 0.5, minus 0.4, and this transistor switches off, yeah. The base of this one also is going up, but it started at plus 0.6, so it goes like plus 0.7, yeah, and that transistor turns on. And by turning on, it connects your negative voltage supply to your speaker, so current passes through your speaker that way, yeah. Now, when it goes the other way, so in your negative half cycle, yeah, the voltage on the base drops, yeah. So this goes, as it passed 0 in the middle, this went back to minus 0.6, this went back to plus 0.6. As the waveform goes down, the voltage here goes less, so like minus 0.7, yeah. This will go to like minus 0.5. So this transistor turns more on, because from the base to emitter is now more negative, it turns more on, yeah. And this transistor turns off, because the base is now dropping, yeah. So this one turns off. This will cause the current to flow through the speaker that way, yeah. And that's basically how a Class B amplifier works. It's also known as a push-pull. So effectively one transistor pushes the speaker and the other one pulls the speaker, yeah. It's moving it in and out. When there's effectively 0 volts here, these are almost just turned on, so there's 0 volts there, yeah, and so there's nothing. So when there's no sound coming in, the speaker cone's in the middle. When this one conducts, it pushes, and this one conducts, it pulls, and that's what moves the speaker cone, yeah. And that's your audio. So that's a Class B amplifier. The problem with these sort of amplifiers is efficiency. So basically, if you think about this, when there's current flowing through your speaker, the current's also flowing through this transistor, yeah. Obviously the voltage across your speaker with the waveform is varying, yeah. So because the voltage across your speaker from ground to here is varying, you think about it, the voltage across the transistor is varying as well, yeah. And the variation here of the voltage comes into a formula. So a formula we have is watts equals voltage times current, yeah. So your speaker has wattage, and it's the voltage across the speaker times the current, and the current will depend on the impedance, yeah. What's called impedance. The speaker has an impedance, 4 ohms, 8 ohms, yeah, common ones. But you've also got voltage across the transistor and current flowing through it. So this is also dissipating wattage as well. And the efficiency of the circuit's about 50%. So basically, the same amount of wattage that your speaker is effectively using and generating sound and getting hot, because speaker coils do get hot, your transistors are also dissipating the same amount of power as well. They're effectively wasting that power, yeah. And on low powered amplifiers, that's not really a problem. So you can have a circuit like this with like plus 40 volts here and minus 40 volts here, yeah. And you can work out from the impedance of the speaker what the maximum wattage would be, yeah. And that's just by knowing the current and the voltage. So that's okay. But what happens when you get to high powered amplifiers? These are okay up to about 200 watts, yeah. Up to about 200 watts. Once the amplifier is more than around 200 watts, dissipating this heat becomes a problem, yeah. So if you try to make an amplifier like this that was like 1 kilowatt, you could do it, but you'd end up with a very heavy amplifier with lots of cooling, and it'd be quite a nice room warmer, yeah. It'd be like having an electric fire, basically, yeah, an electric heater, because it's generating so much heat. So to get away around that, there's a few ways, but one of them is the Class G. And this is the Class G amplifier, yeah? And that's what we have. With the Class G, I won't bother putting all this in, but I'll show you how it works. So, your two transistors, yeah? NPN and PNP, yeah? Let's say plus 40 volts, yeah? Minus 40 volts. And there's, well, let's stick it all in. Obviously, this is driven effectively through a capacitor, yeah? In. 0 volts, yeah? Out. Speaker. 0 volts. So there's the same circuit, yeah? That's your Class B amplifier. What a Class G amplifier does is quite clever. It does this. On your supply rail, yeah, you plus and minus, you have a MOSFET, yeah? Usually a MOSFET, could be a transistor, yeah? The MOSFET here, yeah? That's the gate, drain source, yeah? And you have another MOSFET here. Yeah? And these go into the control circuitry. This is the gate, yeah? Gate. And the other side of the MOSFET is another voltage supply. Let's say minus 80 volts plus 80 volts, yeah? And the way this is designed to work, that when the waveform coming in is at a low amplitude, it switches these MOSFETs off. So you've got plus and minus 40 supply, yeah? But you know yourself, music has, in particular, it's very dynamic. So there's times when it's very loud, there's times when it's quiet. And there's also, like, you know, often a rhythmic sort of boom, boom, boom. And every time you get the boom, 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 it takes a lot of power to drive the speaker, yeah? So this circuit works in such a way as this gate effectively monitors this input circuit. There's obviously control circuit in between, but the gate monitors the input, and when it knows the audio is above a certain level, it switches on. And when these switch on, your supply voltage to these transistors goes up to 80 volts. So they can now deliver far more power into the speaker, yeah? But by doing so, they're obviously dissipating more heat because the voltage is increased, yeah? So, what's equals voltage times current, yeah? So when the voltage increases, and the current increases for that matter, because the resistance of this is fixed, yeah? The wattage goes up. This is why if you have an amplifier and you turn the bass up, it gets hot. Because it's just effectively putting more power to the speaker and wasting more power in the amplifier, yeah? So the idea of this is that these switch on and off when they needed to switch off, yeah? Just by monitoring the input, you know, the amplitude of the signal, that's it. That is a Class G amplifier. Now, the reason I know we have a Class G amplifier here, there's two reasons, which you may have picked up on, I mentioned. One reason, I said this is quite complicated, there's a lot of circuitry in here on each channel, yeah? It seems to be a complicated circuit. That was the first thing, yeah? The second thing, when I started measuring voltages, yeah? And I said, oh, I've got plus 88, and somewhere else I measured like a plus 44. And as soon as I measured those voltages, I knew straight away I'm looking at a Class G amplifier because it's this, yeah? And I then said, well, there should be positive and negative. So I mentioned, oh, I should find a negative somewhere. So I should also find a minus 44 and a minus 88 on both left and right channels. And I couldn't see them. Yeah? Maybe I didn't look at the right place, but I think I did. I couldn't see them. And that's why I knew what I was looking at. And now I hope now that when you next look at an amplifier, you'll know what you're looking at, yeah? This is the more common. This sort of circuit, and the Class AB, which is a version of this, Class AB, it's a modification of this. That's the sort of thing you will find in domestic stereo equipment. Now you'll find Class D, but we're not going to talk about them today because we don't need to, but I'm sure when we come to fix one, we'll talk about Class D. If you want to know, you know, you can go online and look up amplifier classes, and you can have a look at A, B, AB, C, no, C isn't an audio amplifier. A, B, AB, D, G, and H. Yeah, those are the main ones. G is voltage rail switching. Yeah, and that's what we have. We have a voltage rail switcher here. Okay, so now let's have another quick look at the amplifier and see if we can see these voltages. So now we know what we're looking for. So we're expecting to find positive and negative voltages going to each amplifier, yeah? And looking down here now, I've noticed that some of these wires are actually they have symbols like, so you have like 0VL, 0VR, so these will be like your 0 volts, the green ones, yeah? This will be your 0 volts. So if we stick into here, I'm sure this will actually go to the chassis as well. So if we want to adjust resistance, yeah, that's chassis, so that's your ground, yeah? We can, no, I'll stick it in here, it's probably the best place to put it. It's not going to fall out, I don't think. Yeah, stick that in there. So that's your 0 volts. Now these ones here are marked LVR, HVR, LVL and HVL. So that is going to be low voltage left, high voltage left, LVL, HVL, and it's saying plus, yeah, so plus LVL, so that's positive low voltage left, positive high voltage left, positive high voltage right, positive low voltage right. So that's your 4 there, yeah. And then looking down under here, a bit hard to see, but there's some more wires, and these are, I can see things like minus LVL, minus HVL, yeah. So that's your negative ones. So that also kind of explains why we have 8 fuses, because we have 4 voltage rails going to each channel left and right, yeah. So one of these will be high voltage right, low voltage right positive, high voltage left, low voltage left positive, and then these will be the negatives, yeah. So what we can do is we can put this onto volts, yeah. We can switch this on, and I'll check on the fuses first to see what we have. I know the fuses are okay. That's the 88, so that's one of the high voltage, yeah. That's 88, that's another high voltage. Those are positive, yeah. I'm actually expecting these probably be, yeah, 44 positive. 44 positive. So that's the positive supplies. These fuses will be the negative supplies. Minus 44, yeah. Let me move my little camera in a little bit. I'm sure you can see it, but there you go. So there's your positives. Plus 88, plus 88, plus 44, plus 44, and then the negatives. Minus 44, minus 44. Minus 88. Minus 88. Oh, do we have a blown fuse? I just couldn't see it. You see there's a voltage missing. Minus 88. Minus 88. So first of all, yeah, I thought I tested all these fuses. I'm on one end of the fuse, and I've got the voltage on the other end of the fuse. I haven't. Also notice this LED that's lit here. That says left fault. And back there's another one which says right fault, so left fault is lit. And it looks like we have a fuse here. I swear when I tested these fuses they looked okay. Might have to just take a little while these capacitors discharge. I can't probably measure the resistance until, yeah, it's still a lot of voltage in there, yeah. I can see this fuse has gone. Can't even measure the resistance of it. I'm not sure I can. Well, there's voltage in these capacitors. I'm sure the short circuit ones I can because there's no voltage across them. Yeah. Yeah. But this one. Oh yeah, it's reading like a bleep because the voltage. I think that's what probably fooled me originally. So I take it out. I don't want to short anything while they're still charging these capacitors. I'm going to check it out and just wait until they discharge. I mean, it's difficult enough fixing these things it is without, never mind without making yourself more and more problems. Yeah. Let's see if I can, without breaking the other one. That's a remarkably difficult place to get at. Can we use the long nose pliers? It's just broke. It's just broken to bits. Got bits of glass everywhere. All we ended up with there was bits of glass everywhere. Oh dear. Not a problem. I'll tip it upside down and shake it out. Okay, so that's a 10 amp fuse. So I think the reason I didn't find that when I was measuring, I was probably listening to the bleeps rather than looking at the meter, and it probably bleeped because I was charging these, and I thought, oh, I've got continuity. Okay, that's the first problem there. So we got a blown fuse. It doesn't say why, but it does say we have one. Let's see if I can find a replacement fuse and get these bits of glass out of this amplifier. So obviously, one thing you need to keep in your workshop is a good stock of fuses. You know, you never know when you need them. 13 amp, 6 amp, 6.3s. I think these say 10. I think these say 10 on them, yeah. So I just have them like a little bags just with little bits of paper, yeah. 5 amp. And they're kind of like rated like 2.5 or whatever, and I have another drawer with all the small value fuses right down to a few, you know, hundreds of milliamps, or even less. So let's see if we've got a 10 amp fuse here. Fuses come like a fast blow and a slow blow, and I'm not sure what that one was. I have the two metal ends here, so I know they're not in. I know they're not in the amplifier. Let's see if they're actually marked in some way, so I can see what that actually was. Yeah, this end's got markings on it. So let me have a look. Let me see what I actually have here. Yeah. So I have T10A. T, I think, is the time delayed one rather than the F, which is a fast one. Now, let me have a look at my replacement. Yeah, T10A. Well, T10AL, but they're both T10A, so I think we can stick that 10 amp fuse in there. Went in a lot easier than the bloody one didn't want to come out. Alright, let's. There we go. So yeah, so we put a fuse in. Let's get our voltmeter again. Let's see first off. Actually, I have a power disconnector. Before I just do that, I want to look for you know, short circuits. Why did this fuse blow? Yeah, why did it blow? So I'm going to ground. Let's have a look. 0.3 ohms. That's also reading 0.3. I think I still have some charge in these capacitors, so much so that I can't take an accurate voltage reading. Yeah, volts. No, not anymore. Not anymore. So whereas you wouldn't really notice it. Go on the ohms range. That's reading very low. Also reading very low. That's a capacitor charging. Yeah, that's fine. Reading very high. Very high. Very high. Very high. I mean, like mega ohms, you know. There's definitely something different on the negative supply side. That's reading 0.4 kilo ohms. 0.4 kilo ohms. And these are reading very low. So I don't think there's any point as switching this on. Something caused that fuse to blow. And I'm surprised the one next to it hasn't blown actually. I'm very surprised the one next to it, which is reading a low resistance from one end, hasn't also blown. Let's have a quick look. Let's just take that as circuit just to be sure. So we can get under this one and lift the damn thing up. Yeah, that one's come out. I only need to lift one end of it, yeah. Now I can measure it. It looks intact. What's this reading to ground now? High. So I'm guessing this end reads low. Something not right here. Something definitely not right here, guys. Where is it? That's the question. I suppose really the thing to do now is to start taking off all the connections going off down to the amplifiers. These things, yeah. I mean, they're all marked colours, so violet, red, and brown, pink. I'm not too worried about that end. It's more the other end. I'm probably have to take these off to get to the other ones. Okay. Violet, red, brown, pink. Whole massive green ones, and this is the cable for the fan, so we'll have to take off the thing and the little clip, yeah. Get rid of that. Okay. These greens will all be connected. They're all green. They're all ground, so it doesn't matter which one goes where with these. They just, yeah, ground. I assume they're all connecting together. Let me just measure. Yeah, I'm pretty sure they are. Now those two connect together. Yeah. Yeah. I think if they weren't all connected together, you'd have a different colour on one of them anyway. Green. That's them out of the way. Now we can get to the other ones. Blue. Have some fun getting these back in again. There's ones down here anyway. Blue. Black. And they're all marked on the board. All marked with the colours. Blue. Black. A little bit fiddly to get out, but there's still white, grey. Come on. And the last one, yeah, last one. Great. There we go. So that's all the power connections off here, yeah. So have a look now what resistance we got on these fuses. This one was reading low. I still think there's some charge in these capacitors, hence the strange readings I'm getting. But the low resistances have gone. Yeah. And these are reading yeah, positive voltages. There's a little bit of charge left in these capacitors, and it's kind of giving me some slightly strange readings. And I bet it's not much voltage. You see, just a small 0.1, but it's enough, yeah. So if you do see strange readings like that, that's often why. Okay, so the two fuses which were going had the low resistance. Which wires did they go to? Which wires did they go to? One of them, this one goes to black, yeah. It's reading to black. And also to white. Where's the other one going? Why are these two connected together? Oh, it's high voltage left and high voltage right. They just go to the same together, yeah. So these two obviously connect together as well. Low voltage left. No, they don't actually. Strange. Look at this side. High voltage left, high voltage right. Yeah, those connect together. And those connect together. So the two low voltage right and left go together, and the two high voltage, I'd expect that to be the case. So this one, the two low voltage left and right go together. And they don't. So it's the high voltage ones that don't. Is there any more fuses blowing down here? Yeah, that one. Now it's all starting to come together. Okay, so we have another fuse. That's why that one wasn't weren't connecting together. Another blown fuse. 10 amp. Yeah. No, 6.3. We have two 10 amps on the high voltage, I think. These are 6.3 amps. Let's just check it. Yeah. Yeah, 6.3. This is why, guys, you need to have a selection of fuses. This is why you need a selection of fuses, because fuses go because fuses are meant to go, yeah? And you need to have the fuses. 6 amp, 6.3 amp, yeah? And you need a good selection of fuses. You could probably have a look on Ali. We'll have a look, let's see if I remember to have a look at it a bit. See if we can actually buy like a complete range of them. Because this is something you've got to have, yeah. This is something you've got to have. Unless you're living somewhere where you can easily just get what you want, yeah. That's not a 6.3 amp fuse at all, that's a 630 milliamp fuse. That's in the wrong place. So another one. I looked at it, it says 630 milliamps. What's this one? Yeah, that's a 6.3. The other one's in the wrong place. Okay. Fuse in. So now we should see high voltage left, high voltage right, connect together. Low voltage left, low voltage right, connect together. So that's the same as the other channel. So the short circuit, it looks like it's a short to ground, is on which wire? It's one of these blue, black, grey. Blue's okay. Black. That one black. And grey. No. I know it's just on one. It's just on one. By the looks of it. That's okay. Black. Low resistance. Grey. Looks okay. White looks okay. Yeah, so it's on the black. Which is black is high voltage left. High voltage left's got a short. Okay. Which is left? Well, easy way to tell this. Okay, right. The purple and the red go to this one. I can see just under here is purple and red. Yeah. So purple and red is, let's see, violet and red is left. Ouch! One of these spikes, one of these spikes went up the end of my fingernail. This is left by the looks of it, so the black looks like it goes to this one. I can see blue. I can see grey and white going down here. Yeah, black goes to this one. It's there. That's a good channel, yeah. Let's zoom the camera out. You can see it. Okay, so yeah, black one is here. Is it there? Black one's here. So this is your short, yeah. You've got a short on this channel here. This one, that's the other channel, it's okay. Almost certainly the short will be on the output devices, yeah. These things. See, that one's okay. Lead low resistance. So we seem to have a problem, I'd say, on here. So now we need to get this out of the unit. So we need to figure out what holds all this together and see if we can get into that. Okay, we'll see in a few minutes and I've figured out how to get this apart. Okay, so we're getting down to the nitty gritty now. I've got the amplifier module out. It was actually holding like 4 push-in clips from underneath and took a little bit of figuring out, but anyway. So here we have the 2 halves of the board, yeah, and we can see now that there are power devices top and bottom, yeah, and there's 4 transistors here and there's 4 transistors here. So effectively we've probably got the positive and negative half. I'm guessing, you know, like one board is all the top end and one board is all the bottom end. Maybe. I mean, I haven't checked it out, but it's possible that's the way it is. So I thought, well, I could desolder the base and emitter. This is the collector. I could desolder the base and emitters and figure out which one's short. Well, if there is only one short, I've then got to take this apart to change them. So I might as well split it into the 2 halves now. It's looking like there's 4 screws here and the same on the other side, yeah, and then the thing comes into 2 halves. That's the way it looks. It also looks like I might have a short here between the 2 heatsinks. No, it's just fluff. I thought there was something in there that was effectively shorting them. Looks like there's corrosion here. It's obviously got a bit of corrosion on it one way or another. That probably just comes out of the air here because it's like we're surrounded by ocean. So although we get, you know, constant, very nice breeze, we also get a lot of salt, you know, salt I guess in the air, salty air. I mean, this company power sounded down by the coast near the main resort, so these things have probably been used by the coast, you would guess. So it looks like we just take these 2 screws out here. The heatsink is threaded inside there, yeah. Okay, and then I'm going to have to do the same on this side, which is the easiest ones to get at. The bottom ones, okay. So I'll do the same on this one. So you can see a fair bit of this job is just taking this apart, yeah. We've just got to put it back together yet. Yeah. I mean, fortunately, all the coloured wires are actually marked where they go, so it shouldn't be too difficult to get this back together. Okay, here we go. So let's split the 2 halves. Just get a screw out of here before it goes AWOL. So that's got the 2 halves, and now we have red, black, and yellow, which again they're marked. They're all marked on the board. Yeah, black, that one's marked. Red. Yeah, let's try the yellow one. It's fiddly. Yellow's off. And then we just need the red. Right, okay, so we now have the amplifiers, yeah. 15023, 15004, okay. So these part numbers are different, but they're all the same on each block, which makes me suspect that one amplifier board is effectively this side, yeah, and the other one is this side. So half of these will be PMP and half will be MPN. Let's have a look where the short is. The short was on the minus supply, so I'm guessing whichever one of these is PMP, which I don't know at the moment, is the one that's likely to have the short on it. We may have more than one short. Okay, let's have a look. Nothing there. Nothing there. Oh! No. That's like a capacitor charging or something I can hear. There. There. Two short circuit transistors. All the rest kind of look okay. Let's see if we find the base. Is this the base? 23 ohms. Can't say with them in circuit. 23 ohms. We have to take these short circuit ones out first. That's these two at this end. MJ15004. Okay, let's get the soldering iron out and let's remove these two ones here. They're definitely short, for certain. I mean that's before we can check what else might be wrong with these. But that's short. It's not surprising if they are short. These look like these will be the driver stage. This stage is driving these. It's not unusual if they've run short that you might have blown one of these. And then in front of that looks like another transistor here. They might be drivers. There's two more transistors on here as well. There's transistors all over the place in this, yeah. So it's quite possible we've damaged a number of devices. Okay, but that's not so bad because we can compare with a good channel. I mean, we can always take the other channel off the amplifier that was okay, and then we can start comparing voltages and resistance. Well, comparing resistances, yeah, and that would give us a good idea. Okay, let me desolder these things. First of all, I need to take the bolts out, which they were these, weren't they? This side. Yeah, they were this side. Okay. So the first thing is going to be to undo the bolts. There's bolts that hold each one in basically. So we can find a suitable size socket for that. No, and this is not going to be easy because there's not enough width effectively to get the socket down there. And these are captive this end, so we can't unscrew that end. So this is going to be fiddly. And probably just require a pair of pliers. Can't get in with that. Okay, next of many problems is going to be removing these. I need a socket which is narrow enough to get down between the transistor and the pin. I'll have to go see if I can find something to do that. I have nothing to hand here, I don't think, that would actually do it. While we're at it, let's have a look to see if we can even get these MJ, which one's really? No, the other side. Whichever, yeah, they're all the same. MJ 15004, because if we can't get the parts, there's probably not much point trying to take them out, yeah? Okay, let's have a look to see what we can do. Okay. Oh, come on, wake up again. Okay. I'll tell you what, I just use Chrome. I know it might have actually. Oh, it's loading now. Okay. I was just going to go to use Google Chrome now instead. So, AliExpress, favourite place for components. See if these things are something we can actually get. MJ 15004. Yeah, oh, that's so cheap though. Ooh, 5 pairs for 33 sold. I wonder if these are like the transistors that off the other amplifier board, because these would be like what class as complementary NPN and PNP. So the other board has 15022 on it. Oh, come on. There. Oh, what? No. 15003, 15004. G. You see, these got a G on them. I don't know whether the G specifies anything. When it comes down to amplifier ports, you have to be very, very careful you get the right thing. It may well be, I will ask some of the guys, there's an audio section on badcaps.net, 004 to 004G. Oh, he's saying that's good. He's saying it's an MJ15004. Oh no, it is 15004 G. I need to know what the difference is with the G, if it's something relevant. But yeah, it looks like we can get these things. Looks like we can get them. Okay, so what I'll do is I'll try and find a tool that we can remove the ones which, you know, if I have to get these bolts, I don't have anything to get on there. I have to find something suitable for that. And then we'll take those out. We can go down the board and check for anything else that's short circuit. We might have to order some more parts, but there's no point actually measuring at the moment. There's no point looking for the short circuit at the moment until we remove the short circuit devices, because you know, effectively you can't get the reading that you want. So we need to take those out first. I want like some sort of like tubular spanners. I've seen like tube spanners that's like a narrow long tube. I'll nip down the hardware store and see if I can see something like that, because the ones I've got are not going to do it. Okay guys, we got a fair bit with this one. Sorry, we got a fair way with this one. I'm sure this is something we can fix, but we may have to investigate further to see if there's other components blown as well as these. Okay, so I hope you enjoyed that, and I'll be back shortly with some more tools, and we can carry on with this one. We'll do a part 2. See you soon now. Bye.